We hear from industry a lot that as they hire on people, it takes them 18 to 24 months to upskill them. We want to cut that down into a few months. When students leave here, what they'll be able to do is not only recognize all the machinery and equipment and processes that are out there already, but expose them to a lot of those forward-looking technologies that most industries don't have yet. So our students can be change agents, able to look at a problem. They will have seen a possible solution in our classes here, and they'll be able to then implement that into these older manufacturing plants. This is our industrial IoT lab. This is going to be, out of all of our smart facilities, this is going to be the one true lab environment for students. The factory, the continuous process lab, and our foundry in the basement, that's going to be set up as a production environment. This is going to be a lab environment where students can take a first introductory course into the different devices that run the factory, as well as courses on an introduction to data analytics. Each one of these benches here we're going to be outfitting with different control devices like PLCs and control relays, and teaching principles of industrial wiring and PLC programming, which again is kind of part of that automation that came around in Industry 3.0. Within the Industry 4.0 aspect, we'll start looking at edge devices, and we're going to be pulling in additional smart devices that will be able to utilize that data that we can collect. Each one of these benches are going to have two powerful servers that the students will be able to use for processing AI and machine learning, that will be pulling in the data from the factory's control room, be able to run that and look for optimizations on that. We want the factory and the process lab and our foundry, we want that to be analogous to what they're seeing in actual industry. We hear from industry a lot that as they hire on people, it takes them 18 to 24 months to upskill them. We want to cut that down into a few months. We're aiming to make this as close to a real-life production facility as what they would see in industry. And so hopefully when students leave here, what they'll be able to do is not only recognize all the machinery and equipment and processes that are out there already, but we want to be able to expose them to a lot of those forward-looking technologies that most industries don't have yet. So our students can be change agents that, as these companies want to progress into that 4.0 revolution, our students will be able to look at a problem that that company's having, and hopefully they will have seen a possible solution in our classes here. And they'll be able to then implement that and help bring that new technology into these older manufacturing plants. So as time goes on, we're going to be partnering very closely with industry, and we hope that they can provide us a lot of feedback into the problems that they're seeing in new technologies that they're starting to implement, so we can bring it into our facilities. Everything here is going to be, as we talked about before, very modular. As new technologies are developed and are being implemented by manufacturers, with our students, we'll be able to very easily swap everything in and out because of that modularity. We did just recently partner with Flexware Innovations. They're an Indiana company headed up by a Purdue graduate of ours. And what they're providing is what's called an MES software, or a manufacturing execution system. That is going to be the software that basically oversees the manufacturing process from beginning to end. So as a work order comes in, so imagine if somebody was to place an order online for a product, that online order would get sent to the MES software. That software then would be able to look at it, maybe look at the different customization options that they have, the colors for different parts, or what options they want or not. It would be able to generate a bill of materials, or a BOM, and then it will be basically, that'll be the software that orchestrates the process on the factory floor. So it can then start sending out orders to the warehouse to tell the robots in there what parts to go and grab. It can send out the orders to our injection molder, or the CNC machine, to make a new batch of parts. And then ultimately it will dictate and be able to track as the process goes on. It'll be able to track where in the stage of manufacturing it is. You'll be able to track where it's at on the assembly line, or what part of the assembly line it needs to go to next. And you'll be able to, as well, not only just for one individual order, you'll be able to keep a history of all the orders, so that you can see how many good parts have we made, how many bad parts have we made, We can even start drilling down then, as a forward-looking goal, we'll be able to start drilling down into individual workstations, where are we having pinch points, where are we losing production time, or where are we having scrap issues, things like that.